this video we're going to work on the proof of a limit involving a radical function. In fact, we've looked at this limit in a previous video, but in this example I just want to present an alternative method for doing limit proofs involving square root functions. So in this video I'm going to go directly to the absolute value of our function minus our proposed limit, so absolute value of square root of x plus 2 minus 3. I'm going to use a trick that we've used before. I'm going to multiply this by the absolute value of the square root of x plus 2 plus 3 over itself. And you'll notice what I'm really doing there, if you look at the two absolute values in the numerators, is the expressions inside those absolute values are conjugates. That means when I multiply the two absolute values in the numerators, I'm going to get a difference of squares. Absolute value of square root of x plus 2 squared, which is x plus 2, minus 3 squared, so minus 9. The denominator will just be square root of x plus 2 plus 3. You'll notice that I've dropped the absolute value bars there in the bottom. Since both terms are positive, they're unnecessary. This leaves us with absolute value of x minus 7 over square root of x plus 2 plus 3. And when we eventually write our formal proof, we know that numerator will be less than delta. So what I really need to do now is get control over that denominator. And to do that, we're going to use another trick that we've seen a number of times, which is to suppose that delta is no larger than 1. This gives us control over x minus 7. We know that that will be greater than negative 1 and less than 1. Let's manipulate the x minus 7 to transform it into square root of x plus 2 plus 3. Let's begin by adding 9. And then for each of the three parts in this tripartite inequality, let's take the square root and add 3. Now, since all three of those expressions are positive, we can reciprocate all three. As long as we remember to reverse these inequalities. At this point, you should notice that we have two bounds that come from this set of inequalities. One is that 1 over the square root of x plus 2 plus 3 is less than 1 over square root of 8 plus 3. And in this inequality, we can even take this first expression to be in absolute values. And we also have this inequality. Absolute value of 1 over square root of x plus 2 plus 3 is greater than 1 over square root of 10 plus 3. This inequality gives us an upper bound on the absolute value of 1 over square root of x plus 2 plus 3. This one gives us a lower bound. The question is, which one do we need? Well, if we go back to where we left off, up here, we left off with delta over square root of x plus 2 plus 3, which we can write as delta times 1 over square root of x plus 2 plus 3. Since we are eventually trying to get this expression we're working on to be somehow less than epsilon, what I'd like is some sort of upper bound for 1 over the square root of x plus 2 plus 3. And with this inequality right here, we have that upper bound. In fact, at this point, we can say delta times 1 over the square root of x plus 2 plus 3 is less than delta times 1 over the square root of 8 plus 3, simply because this is less than this by this inequality in the line above. Now, given that this quantity at the end is delta times a constant, if we relate this to epsilon, we have a direct comparison or a direct relationship between delta and epsilon. Equating this last expression to epsilon, we have that delta, that is the delta we want to choose, would be square root of 8 plus 3 quantity times epsilon. Formal proof: given epsilon greater than 0, let's choose delta to be the minimum of 1 and square root of 8 plus 3 times epsilon. Let's assume, as usual, that 0 is less than the absolute value of x minus 7 is less than delta. This implies that when we look at our function minus our proposed limit, which would be square root of x plus 2 minus 3, well, if we follow our algebra from above, scrolling up just to remind you, in our scratch work up here, we showed that the absolute value of square root of x plus 2 minus 3 is actually less than delta over square root of x plus 2 plus 3. So I'm just going to write less than delta over square root of x plus 2 plus 3. Now, since we chose delta to be the minimum of these two numbers, that means delta is less than or equal to 1. If delta is less than or equal to 1, then the inequality that we derived above in our scratch work, that is the one that says 1 over the square root of x plus 2 plus 3 is less than 1 over square root of 8 plus 3, applies. This last quantity is less than delta over square root of 8 plus 3. Let me write that as delta times 1 over square root of 8 plus 3. Now, since delta was chosen to be the minimum of 1 and square root of 8 plus 3 quantity times epsilon, we also know that delta is less than or equal to square root of 8 plus 3 times epsilon. So in this last step, we can say that delta is less than or equal to square root of 8 plus 3 quantity times epsilon times 1 over the square root of 8 plus 3. That leaves us with simply epsilon. Therefore, by the delta epsilon definition for limits, we have that the limit as x approaches 7 of the square root of x plus 2 is equal to 3.